So the overall idea in this assignment is to ease you into the idea that adding and multiplying are not the same, though they both involve the denominator. So let me ease you into this, okay? So looking at 5.2, okay, what ends up happening is we have here the same denominator. So what do? You literally just add the numerators together. Like that's all you do. Like if you look at this problem and you're like, this problem seems really easy. It's just 4 over x squared. That is correct. That is the answer. Don't forget your domain restriction that x cannot equal 0. And that's how the entire first row is. I mean, look at the first row. Here I have the same denominator. So all I'm going to do is add these numbers, and then I'm going to add these numbers. And I'm going to write that denominator down. The third problem, all you're going to do is you're going to distribute and then combine like terms, maintaining the same denominator. Okay, and then you come down to number 4, and I'm trying to ease you into this. By the way, the same thing happens on B here. It's actually the same kind of idea. And I want to tell you a funny story. When I was a kid, I had a brother. Me and my brother sat right next to each other at the table, and if he got more tater tots than me, I would count them. If he had 8 and I had 7, I literally was like, that's not cool. Where's my other tater tot? Now you might be like, why is Mr. King talking about food? Because look at this. These are the same. But this one has 2 and this one has 1. It's just like me at the table when I was an 8-year-old. I want my other x minus 1, so I have the same amount as the other one. And then you multiply and combine like terms. Okay, over here, this has nothing in common. There's no GCFs. So all I do is take this entire thing and I multiply it here and on the numerator, right? This is like, you know, you go over to your friend's house and you guys show each other what you got for your Christmas, birthday presents or whatever. And you just basically say, I don't have that, I want it. And you, when your friend leaves, you say, hey, I noticed that my friend had blah, blah, blah. I'd like that too. The same thing happens here. This one looks over here and says, I don't have that. Okay, so it wants that. So it wants what it doesn't have, just like human beings. Same thing here. Okay. Then we come down to a problem like number 8, and I want to show you what you don't want to do ever in your life because the problems are not supposed to be this hard, okay? So when you're doing addition, you never want to make this mistake. Everybody listening very carefully to this because this is the thing that makes people literally go into a tizzy. They just don't know what's happening, and they feel like, I thought it was easy. Well, watch this. This thing right here and this thing right here factor. You do not ever want to do this. I'm going to take this entire quadratic and I'm going to multiply it here and here. Let me be very specific about this. If you have to multiply together and get a cube, that's the wrong way to do it. There will be no cubes unless you have to factor them. Let me say that again. Don't make a cube. If you have made a cube, that is bad. So let me go through this problem in its entirety because it kind of encapsulates the other problems. I'll go back and look at those with you in just a minute. So like here, this one would be x plus 2 and x plus 1. Okay. And then here, this one would be x plus 2 and x minus 1. Okay. Again, the way you factor is you say 2 is 1 times 2 and you add to get 3. This is 1 times 2 and you subtract to get 1. So I'm just double checking that I got it right. And here's the thing you have to avoid. When you look at 5.1, what are you doing? Crossing things out everywhere. But in 5.2, this is why I say it's really a good idea to do 5.1 and 5.2 simultaneously at the same time, is you say this basically. You say, hey, look, I have this factor in common. Check, I have that in common. This does not have an x minus 1. So that's what you put here and on the top. And then this one doesn't have the x plus 1. So I put that here and on the top. Your job here is to make sure that they are equivalent denominators. And by the way, doing this produces the least common denominator. Okay. So here's what you do as a check. You write your denominators down, and you could write them out of order to begin with, just to make sure you have the same denominators. They don't have to be in order until the end. Okay, so that one is that. And then here I have x plus 2. X minus 1 and hold on a second. See, I made a little boo-boo. It happens. That's supposed to be a 1. I even said 1, and I wrote down a 2. So that's why that's such an important step, to make sure you didn't make a boo-boo. I wish I made that mistake on purpose, but that was a complete accident. It's very easy to do. Okay, so I even said x plus 1, and I wrote the wrong thing down because I wasn't paying attention. So that way I just check, yep, I have the same denominators. And then up here, if you want to, you can box this, but I want to show you again how easy this is to not box. X squared, and then you add these two numbers, which is negative 4x, and then you multiply those two numbers, positive 3. That's exactly how you factor. So why shouldn't you FOIL the same way? Think about what I'm saying. So same thing here. We have x squared. We are going to add these two numbers and get minus 3x, and then we're going to multiply those numbers and get negative 4. Okay, and so now what I do is I write down the denominator in order from smallest to biggest, x minus 1, x plus 1. Some students don't pay attention to this step, and this is the step that catches your errors so you don't go insano. So make sure you do that step. And then you distribute your negative sign like we learned in Unit 1. What I'm going to do there is I'm just going to write that right here, negative x squared plus 3x. I'm writing it in red so that I remember that I actually distributed the negative. This one will just drop down, and then I combine my like terms and state my domain restrictions. All right, so that's the process for adding. The process for adding is longer than it is for multiplying, which sounds weird. Like when you're a little kid, you think that adding is easier. And then you realize later in life that adding is actually harder than multiplying. It is. It's a weird thing to understand. Okay, so our final answer for this problem, it comes out to the x squares cancel. They make 0 because we're adding, right? The additive inverse is 0. The multiplicative inverse is 1. Negative 4x and 3x make x. Negative x, forgive me. And 3 and 4 make 7. And then on the bottom, nothing cancels because I don't have anything on the top and the bottom that is the same, right? There's no way that this is going to factor. But if this were a 2, you would want to factor it to see if it cancels. It clearly doesn't because it's a 7. And then I have to state domain restrictions just like I did in the previous assignment. So here I would say x cannot equal negative 2, positive 1, and negative 1. And that's the answer. So what happens as we keep going? Nothing really changes. There's no keep, change, flip here until you do a problem that has combined operations, which we'll look at in a minute. So on the back, just more of the same. What do you do when there are 3 denominators? You just do it again. No keep, change, flipness here, right? So here I would multiply, like I would multiply this by x plus 2. Okay, and luckily in this problem, they didn't give me another one. That would kind of stink. And then I multiplied both of these by x minus 3. And then you would have to multiply the top together. Okay, and so same thing here, but you have to factor. And then same thing here, but you have to factor. And then we get to one that combines all the operations. So let's make sure we understand the process of multiplying. Multiply and divide is factor, cancel, don't worry about denominators. The thing that you cross out is the greatest common factor, by the way. Okay. For adding, we're really concerned with making things equivalent and combining like terms. There is no combining like terms in 5.1, but combining like terms is the whole idea in 5.2. And then you get to a problem like number 17. And it seems like it doesn't even fit. And you're like, what is happening here? This is we got to follow the order of operations. Okay, so let's take a look at how this problem works. It's not as bad as you think it may be, but what it does is it requires you to really understand the order of operations in a problem like this. So what's critical about this is understanding that there's actually a grouping symbol here and down here. And that's something that students, they don't really process it. There is a grouping symbol on the numerator and denominator, which means this problem is actually 2 separate problems. And when you look at it here, I do this all the time where I actually just cover up half the problem. So when I look at just this problem, it's really not that bad. Like, what's my greatest common denominator? Oh, this thing needs an x. This thing needs a y. So I just put an x here and a y here. And this problem actually, believe it or not, it's surprisingly not that bad. I get 2x over xy, and then minus 3y over xy. And that comes out to, it doesn't combine. it comes out to 2x minus 3y over xy. And of course, my order of operations thing got in the way, so I'll move it. Okay, so take it one step at a time. Let me do the other side as well. So now I just need to do the bottom. Remember that the bottom, there's a 1 right here. So my greatest common denominator here is just to multiply by y, right? I just need to multiply by y, and that's going to give me 5y plus 2y over y. I have the same denominator, so I get 5 plus 2y over y, and I just got to remember that the entire problem was really division, and then when I get to here, I keep change flip. And you might be saying, but Mr. King, I thought we were supposed to multiply and divide before we combine like terms. You are, except for the fact that there's a grouping symbol here, and grouping symbols literally mean this is a separate problem. So within the numerator, I had to add and subtract. But then once I finish that, I have keep, change, flip. And that problem, let's take a look at what that looks like, and then we'll do one last one. So we have 2x minus 3y that doesn't change over xy. And then we flip this thing, so times y over 5 plus 2y. And then the only thing that cancels is this little y right here cancels out. And that's your answer. So your answer is y times 2x minus 3y divided by x times, I'm going to put this in order. I meant to do it earlier, I just didn't. It would be 2y plus 5. I could do that at the end if I didn't catch it. And then we have some pretty complicated domain restrictions. They're not that bad. It's pretty obvious to most people that x and y can't equal 0, right? I mean, I can't have an x or a y equal to 0. So that's pretty okay. But then some students get really confused about what I'm about to say. The other one would be to set this equal to 0. Okay, so I'd have to take 5 plus 2y equals 0 and say it can't equal that. And you just got to remember where this comes from. It comes from finding anti-answers, right? So that's the anti-solution. So y cannot equal negative 5 halves as well. And let's see if I have any other denominators. I have this as a denominator, but that's taken care of with the y not equal to 0. I have this, but that's taken care of with y can't be 5 halves. So it looks like I'm good. But you want to make sure when you finish the domain restrictions that they take care of all steps. So as always, we have to make sure we check our work. And sometimes you will do something crazy, checking your work. And this is going to be important on a multiple choice test because most people would not have left that y there. So when you check it over, notice that this y got canceled. And sometimes you have to just double check and be like, oops, I forgot that y. I even crossed it out, and this just happens sometimes as you're doing these problems because these problems are kind of intense and it's very easy to make a boo-boo. Now, that being said, it doesn't change the domain restriction because the domain restriction is we're talking about up here. So it still needs to be there, but just be careful that you don't do work and forget you did it. Look at one last thing, okay, which is what do I do with this thing? This thing is we're really getting back to the order of operations here, right? So what should you do first? Well, there are grouping symbols, as we learned, but they don't do anything. Over here, the grouping symbol required combination, but over here, the grouping symbol doesn't do anything. So what I'm going to do is I'm going to, hold on one second. In this problem, I'm going to keep, change, flip, and then I'm going to find a common denominator, okay? So I'm going to have to keep, change, flip. I have to do this entire problem, okay? And then once I do that problem, I have to subtract 3 over x plus 1 from that answer. One last thing I just remembered. At the bottom of this thing, I put some negative exponents back in here. What do they mean? They mean put it on the bottom, right? So what this means right here is this goes to the denominator. The denominator of what? And I think that's what people need to see. Where in the world does that go? Where does that go? Where does that go? It goes below its coefficient. Let me say that again. This y, this x, and this y, they go to the denominator of their coefficient. So maybe it makes more sense to just show you the top part first. The top part would become 1 minus x over y, because the coefficient of the y is the x. So where does the y go? It goes to the denominator of the coefficient. But on the bottom, some people get really confused. They're like, what's the coefficient? The coefficient on those is a 1. So this would become 1 over x, and this would become 1 over y, and then it becomes the exact same problem as this one. Then it becomes a take care of the numerator, take care of the denominator by multiplying, like this one will be multiplied by y over y, this will be multiplied by y over y, and x over x. So this problem, the first step is really, what does a negative exponent mean, which is super important in calculus. I know that that's weird to say that because we're in algebra 2, but the hardest part of calculus is algebra 2. I'm going to say that again. I know I haven't said that a lot, but it's something that we really start to understand as we take on other chapters. The hardest part of calculus is algebra 2, and the hardest part of algebra 2, are you ready for this, is rational problems, the chapter you're doing right now. That's the hardest part of calculus. The place where kids get bad grades in calculus is in this chapter 2 years from now. How about that?